Alright, so now we're doing strategic investment. Consider a Cournot model of strategic investment from the lecture. Two firms compete in two stages, so we've got two firms, two time periods. In time period 1, they choose investment levels that lower production costs, so you can think of the investment lowering the marginal cost. So that happens in time period 1. And then in time period 2, they choose quantities. Suppose that both firms can simultaneously, so this isn't like a sort of one firm picks their level and then the next firm pick at the same time, can simultaneously invest in stage 1 to lower their production costs. So investment, again, happens in stage 1. Firm 1 chooses K1, firm 2 chooses K2, and then in stage 2, they choose quantities and then just compete the way they normally would. This is the cost function. So here we've got 90, which is the marginal cost, and then the level of investment is subtracted from that, right? So as Ki goes up, say it's 10, that brings the marginal cost down by 10. So your investment brings the marginal cost down, which pushes your cost downwards. But the force opposing that is over here, this Ki squared, which means that as you increase your investment, your cost increases. So there's a force pushing the cost down and a force pushing the cost up. We've just got a standard inverse demand function, nothing too tricky here. And then for the first question, for any given K1, K2, solve for the Nash equilibrium of the Cournot game played at stage 2, so we're backwards inducting. In particular, derive each firm's profit function, profit I, best response function, Qi is a function of Qj, and the equilibrium quantity Qi. Okay. So, first thing we'll do, since there's only two firms, I'm just going to do 1 and 2 for now, just why not? So profit 1 is obviously going to be a function of Q1, Q2, and K1. And it's going to be equal to the price, which is 300 minus Q1 minus Q2 times Q1. So that's price times quantity. And then, of course, we got to minus out the cost, right? Which was 90 minus K1 times Q1 minus K1 squared. And then again, that's a minus. It's a minus because it's, yep, cool. Then we expand it out, and it becomes 1 Q2 minus 90 Q1 minus K1 Q1 minus K1 squared. Okay, and then we're going to come back to this later, but if you were to simplify firm 1's profit function...
Isn't it plus K1 Q1?
Indeed it is. Boom. Correct. My bad. Had a protein bar and a 7-Eleven coffee for breakfast today. Breakfast of champions. Q2 plus K1 Q1 minus K1 squared. Okay, so this is firm 1's profit function. And if you could just write this down or make a note of it, because we will come back to it. But for now, we are going to work with this one that we just derived. But these two are the same thing. We're gonna need this a bit later. Okay, so what do? Of course, we do our favorite thing. We take the first order condition. And what are we going to get? We're going to get 300. We're just working with this one again. Why? Because I've got it down this way, so let's not deviate. Q2 minus 90 plus K1 equal to 0. It's equation 1. Without doing it all over again, we know that the two firms are again symmetric, so we just swap the Q1s and the Q2s. So this becomes 2Q2 minus 90 plus K2 equal to 0. Cool. Cool. Alright, so they're the profit function. That's the profit function part of the question. If you were to rearrange these two equations, equation 1 and equation 2, so rearranging equation 1, we're just getting the best response function here, just because it asks us to, although you don't strictly speaking need to. If you were to rearrange it, it just becomes 105 plus K1 minus Q2 on 2. And if you were to rearrange equation 2, you just get the best response function for firm 2 as 210 plus K2 minus Q2 minus Q1 over 2. So that's just rearranging those to get the best response functions. Although, as you probably noticed, I never really tend to get the best response functions unless explicitly asked to. So what do we do now? We're going to get the quantities as a function of the level of investment. So to do that, we go equation 1 times 2. That's going to be 600 minus 4q1 minus 2q2 minus 180 plus 2k1 equal to 0. And we just stick equation 2 in as is. And we're going to take the difference y, because we're eliminating Q2. And that comes out as 300 minus 3Q1 minus 90 plus 2K1 minus K2 equal to 0. Good, so now we've got Q1. And all we have to do is solve for Q1. Two. $210 plus 2K1 minus K2 on 3. So that's how you get firm 1's quantity as a function of the level of investment. So that's the first stage of these kind of questions. They say, okay, cool. In time 1, you invest. In time 2, you compete with quantities or prices, whatever. And then when you're doing it, first you backwards induct, so you get profits, like we did initially. Get profit as a function of quantity 1, quantity 2, and the level of investment for whichever firm you're working with. You take the first order condition for as many firms as you're working with. You solve the system of equations, the system of first order conditions. When you solve it, you'll get one firm's quantity as a function of both of the investment levels, right? So we're just backwards inducting. And because the firms are symmetric, all we have to do is just swap the 1s and the 2s, right? So then that's going to be and that, or rather these are the equilibrium quantities as a function of investment. Now, are there any questions about that? Yes, that is the 3. Thank you. Jeez, I'm like super off today, hey, more than usual. Cool. Now, was that everything we needed to do for this part? Drive each firm's profit function, check. Best responses and equilibrium quantities, good. Alright, so now we're after an expression for each firm's profit at stage 2 as a function of K1 and K2. Now we're going to go back to the i's so that we get comfortable with both. So firm I is going to have a profit equal to 210 plus Ki minus 210 plus 2K1 ki minus kj over 3 minus 210 plus 2kj minus ki on 3. My stylus is dying. Multiplied by 210 plus 2ki minus kj on 3 minus ki squared. Alright, so if you remember the green box that I asked you guys to take a note of before, this is just subbing in the values. So this is qi, this is qj, or you can think of this as q1 and q2. This is this is qi obviously because it's multiplied in, and then minus the level of investment over here. Firm's profit.
What are the costs?
What about the cost? I was literally just thinking that. How is it possible that I got the right answer? The cost is factored in. That's fine. So, just as a refresher, we had firm, we'll call it firm I. Their profit was 210 minus Q1 minus Q2 plus K1, Q1 minus K1 squared. Alright, so this function here is the one we had written down earlier that I asked you guys to take note of, and it is exactly the same as that. How did we get the green one? We got the green one by simplifying 300 Q1 minus Q1 squared minus Q1 Q2 minus 90 Q1, so this is bringing in the cost now, plus K1 Q1 minus K1 squared. Alright, so this profit function here has the cost factored in, so here's the 90. And the investment level, so this part over here factors in the cost, and then when you simplify it, 300 minus 90 is going to be where the 210 comes from. So the cost is factored in. So we end up with this green one, which we got earlier, and then when you sub in Qi and Qj, or Q1 and Q2, whatever you like, we end up with this massive expression over here. And then what do? You simplify it, obviously. So, where should we do that? Have you guys gotten this down? Can I just sort of move somewhere else, or do you need to see it? Alright, if there are no objections, I'm going to move somewhere else. Stick with purple. So when you simplify the expression one line at a time, you get 210 plus Ki plus 420 Kj over 3. Genuinely just a bit curious.
Worried.
Yeah, I was like, do they make mistakes while they're doing algebra? Is it just me? What's going on? 6:30.
The other classes we've had have generally been easier math.
Okay.
That's the difference.
Good. Good. That's what I want to hear. Okay, and then, you know what? So I'm skipping a step, but all I'm doing is multiplying this bit up by 3, and then taking the difference between the two fractions. So if you multiply this up by 3 and you take the difference, you end up with 2ki minus kj on 3 squared. And then after the pain is over, you end up with J3 squared minus Ki squared. So that's what you end up with. Once again, don't get confused this. We just multiply it by 3. So 210 multiplied by 3 is what, 630? And then 630 minus 420 is going to be 210. So that's where that comes from. Similarly for the Ki. Now, is that it for this part?
So that was,
Okay, sorry, what?
so that was when they're solved simultaneously.
Yes, yes. So right now everything's both firms interact at the same time, and then
That's their profit.
yep. So this is firm I's profit, so it could be 1 or 2. Firm I's profit.
And then you'd swap it for the
Yeah. And it's a function of the two investment levels. So that's the idea. First, you want to get the best response functions, if you will. So you in the first part you backwards induct. So you get the profit as a function of Q1, Q2, and the level of investment. You take the first order condition for both firms. You solve the system, and you get the best response function of, say, firm 1 as a function of firm 2. So you get quantity as a function, Q1 as a function of Q2 and the level of investment. And then that allows you to sub it into a profit function and come up with this expression. So now you have profit as only a function of the investment levels. You've essentially eliminated the quantities. Also, this expression, like the other green one, will be important later, so I would write it down. Alright, so the next thing we do is we find the equilibrium levels of K1 and K2. In particular, derive each firm's best response function, and then solve the symmetric equilibrium, blah, 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 blah. What's the profit? Okay, so again, our favorite exercise. If you hit the profit expression that we just used, or rather if you differentiate it with respect to K1, you're going to get plus 2K1 equal to 0. And then if you solve that, it's going to be 420 plus 4K1 minus 2K2 over 3 times 2/3 minus 2K1 equal to 0.
Sorry, where did the 2/3 come from?
The 2/3 came from... So yeah, you have to use the chain rule on the profit function. I put the green box around. If you hit it with the chain rule, first you bring down the 2, the exponent, and then you have to differentiate the inside. So differentiating it with respect to K1, you can say that the numerator of this fraction is just going to be a 2. If you this part inside the box is as is in the old profit function. When you're differentiating the inside, differentiating the top with respect to K1, it just becomes a 2. Does that make sense? You don't, yeah? No? Okay, hold on. Go back and I'll show you. Where's my green?
Will we need to know the chain rule, do you think?
Yes. Yes, it's quite likely. I mean, you can always simplify it. So this thing you could if you did not know the chain rule and you had a bit of time, you could expand it all the way out, and it would end up just being like a quadratic, and then you could use the quadratic formula, right? But there's so strictly speaking, yeah, I'm gonna stick with my answer is yes. You probably need the chain rule. So remember, the chain rule says that a function has 2 parts, an inner bit and an outer bit, like we covered in the first one. In the first lecture. So if you were to differentiate this, I'll stick with purple, we're going to say that this is the inner bit and this whole thing is the outer bit. Alright, so if you differentiate the outside, you just bring this 2 down. So that's where the 2 comes from. It becomes 2 times the inner bit, which was...
Oh, and then you differentiate the inner and you times it by the inner.
Yeah, by the outer, and that's why that's where the 2/3 comes from. But just because people do seem a bit, this is a plus, this is a k1 minus kj over 3. And then we have to differentiate this part. And then you can see we're differentiating with respect to k1. There's only a k1 here. Using the power rule, it just becomes 2, but it's part of a fraction, so it becomes 2 over 3. And then, of course, you have to differentiate this bit, which just makes it minus 2k1, using the power rule over here. So that is how we ended up with this. And then we're still on our simplification journey. What am I up to in the notes? And then you multiply obviously the top and the bottom. You just multiply straight across and it becomes 840 plus 8.
We get carried errors.
Pardon?
We get carried errors.
I don't know what that means.
Like, so say if you make a small error in your...
Oh, and you carry it on?
Yeah.
No, it's alright. Okay, and then remember, we know that the firms are symmetric. So this expression can simplify to a very nice 840 plus 4k over 9 is equal to 2k over 1. Right, so here we've just said k1 is equal to k2, so that's where the change in this fraction came from, and we just take this over to the other side. And then we just cross multiply. Where are we at? 840 plus 14. Wait, no, I screwed up. 840 plus 4k, okay, there we go, that's where I screwed up, is equal to 18k, and then this becomes 14k is equal to 840, and thus we get k star is equal to 60, which is going to be equal to k1, which is equal to k2, because we're dealing with the symmetric firms. And then to get the profit of both firms, so let's just say firm I, all you have to do is substitute the k's in. So the profit function was 210 plus 2k1, we know k is 60, minus k2, which we know is 60, or kj, over 3, this term is squared, minus 60 squared. Spit that in your calculator, and both firms are going to make 4,500. So again, just a bit of context for what we've been doing. We said you know what, I'll write it down. In the first stage of the game, firms choose investment, and in the second stage, they choose quantities, and that results in profits, right? So how do we solve this kind of game? The first thing you do, so just almost as like sort of a menu. The first thing you do is you get profit as a function of Q1, Q2, and K1. So this would be profit 1. Then you get the first order condition for firm 1 and 2.
Is it highly likely that we'll get more than 2 firms?
Oh, like in the exam. So as I said, I haven't seen the exam. I can't guarantee anything, but my opinion would be probably not.
Probably not.
More than 2 firms. I would say probably not, but I can't guarantee anything. More than 2 firms complicates things, and the idea, yeah. So it seems unlikely in my view. So you get the first order conditions for firm 1 and firm 2, and you want to get QI, or stick with 1 and 2. Function of Q1. Once you have that, you can get Q1, oops, K2, and Q2 is a function of K1, K2. Step 5, then you get the profits as a function of the 2 quantities, the 2 levels of investment. Then you get K star, and that'll give you the profits. Right, so that's just a sort of overview of what we've done. Because I know there's a lot of math, so it's hard to keep track of what's going on. Okay, now suppose the firms cannot invest in lower costs at all. So there's no investment. K1 is equal to K2, which is equal to 0. What are the equilibrium quantities and profits in this case? Are the firms better or worse off? So there's a couple ways you could do it. You could just run the Cournot, and that would give you an answer. But why bother? We've already got this vertical line just means given. As a quick refresher. We know that profits are equal to 210 plus 2ki minus kj on 3 squared minus ki squared, right? We know profits are equal to that. We know that nobody's investing, so we just sub 0 in everywhere we see a k. And that all that just reduces to is 210 on 3 squared, which is equal to 4,900. The profit before, when they do invest, when k was equal to 60, the profit before was 4,500. So clearly they're better off without investment. Are they better off not investing? Now, consider the example we solved in the lecture where firm 1 chooses K1 while firm 2 cannot invest, as if K2 is equal to 0. What are the equilibrium profits in this case? Which firms benefit from ability to invest in this case? So, where firm 1 chooses K1 while firm 2 cannot invest. So again, from part C, we had the first derivative for firm 1's profit with respect to K1 was equal to 840 plus 8K1 minus 4K2 on 9 minus 2K1. So that's we solved that earlier in part C, right? So this is from part C. That's where this is coming from. I'm not just sort of pulling it out of my ass. And the idea is, now that you know K2 is equal to 0, this becomes 840 plus 8K1 on 9 equal to 2K1. 1. And then it becomes 840, 2K1 minus 8, this is still over a 9, 8 on 9, K1. So what do we end up with? We end up with 840, on 9 should be equal to 10 on 9. K1. And then all you do is multiply both sides. So you're multiplying both sides by 9 on 10. And you get that K1 star is going to be equal to 84. So this just means you're multiplying both sides by 9 on 10, and this side becomes 84, this side becomes K1. So, finally, now that you've got K1, you can say the profits of firm 1 is going to be equal to 210 minus 2 times 84. K2 is 0. This is the same profit function we were using before. Squared minus 84 squared. And that's going to spit out an 8820. The profit of firm 2 is going to be 210 plus 2 times 0 minus 84 on 3 squared minus 0. And that is going to be equal to 1764. So clearly, if firm 1 does invest and firm 2 does not invest, firm 1 can really screw over firm 2. Cool. Okay, so what would you guys prefer? Question 2 from the last problem set or question 4? Just as a reminder, question 2 was the Cournot triopoly, and question 4 was the shoes, the B Brock or whatever it was, the alike and B Brock or something.
I don't know about everyone else, but I reckon question 4 was slightly easier to question 2.
You want to do question 2? Yeah. All right. I anticipated your answer, and here's question 2. Good. So here, Cournot triopoly, where prior to any possible merger, the firms have the same constant marginal cost and the same fixed cost. So this is the cost function for all 3 firms prior to the merger. Market demand is for a homogeneous product. Is it homogeneous product? My bad. Is described by the same linear inverse demand function, so we just got this. Part A express the profit of each symmetric triopolist as a function of f. Alright, so if we'll just do it for firm 1 and then use the old symmetry trick. So if we just multiply Q1 by this inverse demand function, it becomes 150 minus Q1 minus Q2 minus Q3. Right, so this is revenue minus 30 Q1 minus plus F, and then expanding it out, Q1 Q3 minus 30 Q1 minus F. So that's the profit function of the first firm. Take the partial. Two minus Q3 minus 30 is going to be equal to 0. And because at the moment all of the firms are symmetric, we can just replace the coefficient along. Minus Q3 minus 30 equal to 0. Right, I've been writing ones, haven't I? This is 3, this is 2. Q3 is equal to 150 minus Q1 minus Q2 minus 2 Q3 minus 30 equal to 0. Alright, so here you have it, a linear system, 3 equations, 3 variables. 2 Q3. And essentially you just solve the system. I won't solve the system for lack of time. There are more interesting things to do, but you guys all know how to solve the linear system, right? Yeah, so just take the difference in the equations. A little trick is that obviously because the firms are symmetric, these are all going to be the same. And long story short, are equal to 30. So then if you want to write out the profit as a function of f, it becomes, right, I'm skipping ahead. So if these are all 30, then big Q is going to be 30 times the 3 firms, which is going to be equal to 90. And thus the price as a function of Q is going to be 150 minus 90, which is of course equal to 60. So then the profit of each firm as a function of the fixed cost is going to be the price that they charge, 60, how much they sell, each firm sells 30, minus the cost, which is 30, which is the marginal cost times the output, minus F, and if you stick that in, you're going to get 900 minus F for every firm. So that's the profit of each firm. Now suppose firms 1 and 2 merge, with the resulting industry being a Cournot duopoly. Through the merger, the firms are able to eliminate the duplication of the overhead costs, so that the post-merger cost function of the merged firm is given by this, where Q12 is the post-merger output and F12 is less than 2F. What does this mean? Two firms are merging, right? So essentially it's a double up in their overhead costs. So that's where the 2F comes from, because the two firms are merging. But the merged firm has F12, which is less than double. So what does that mean? If you were to get two firms and combine their fixed costs, it would be 2F. But if you merge two firms together, their fixed cost is going to be below what their fixed cost would have been separately. Okay, so the profit of the merged firm is Q3 minus 30, Q12 minus F12. Right, so all I did here was price times quantity minus costs, nothing special. So this bit is P is a function of Q12, Q3, and this is just the cost function. I remember doing this question back in 2014, actually. We all got together and we were just like, there's 3 firms, what do we do? Minus 2Q2 minus Q3 minus 30 is equal to 0. Yeah, we didn't have YouTube back in 2014. Yeah, no, it did come in very handy, actually. Alright, profit of the third firm, same thing. Where are we up to? Minus Q3 squared minus 30 Q3. Take the first order condition of firm 3. We can't just play our little symmetry trick anymore. Or maybe we can. I don't know. 1, 2, minus 2, Q3, minus 30, equal to 0. And then here, once again, you've got your system. You solve the system, and you're going to get that Q12 is equal to 40 if you solve the system of these two equations and two unknowns. And Q3 was equal to 40 as well because they are symmetric, of course. That's later. Thus, P of Q12, Q3 is going to be equal to 150 minus 80, which means that the price is now 70. So the profit of the merged firm is going to be equal to its price that it charges 70 minus how much it produces, multiplied by how much it produces rather, times the marginal cost, times the number of units, minus its fixed cost. That's equal to 1600 minus F12. So that's the profit of the the merged firm as a function of F. And then in order for the merger to be profitable, alright, so if this condition doesn't hold, there's no reason for them to merge. It's just saying that the merged firm's profit has to be bigger than the sum of both of their profits. And then this is 1600 minus F12 has to be bigger than 900 minus F12 plus 900 minus F12, right? And if you solve the inequality, you get that, we'll do it, may as well do it now, we'll just do it quickly. Solving the inequality, what do you end up with? You get that 2F minus F12 has to be bigger than 200. So it's saying that the savings in the fixed cost, the difference between the two firms, the savings in the fixed cost has to be bigger than 200 in order for the merger to be profitable. Otherwise they wouldn't do it. Cool. So that's this question. Any questions before I jump to the next one? Now suppose that instead of the previous setting, the two merging firms realize savings in the variable cost, and now it's asymmetric. We can't do our fun little trick. To keep matters simple, assume away any fixed costs before the merger. Thank you, Emil. Let the post-merger cost facing the merged firm be CQ12. So where C is less than 1, it's kind of like a discount on the marginal cost. So compute the post-merger profits of the merged firm. Okay. Okie dokie. So first things first, nothing has changed for firm 3, the firm that isn't merging, okay? So we can write firm 3's first order condition as 150 minus Q12 minus 2Q3 minus 30 equal to 0. We've already derived this, nothing's changed for firm 3. However, the merged firm is a little different now. $30, which is the marginal cost, times how much the firm produces, multiplied by this little discount C. The discount's important. The discount is what makes the difference. Two minus Q3 minus 30C equal to 0. So see, the C is still here, and now everything, the price, the quantity, blah, 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 is all going to be in terms of this little discount. So we'll call this equation 1, firm 3's first order, and we'll call this equation 2. We're going to have to solve the system. We're going to do it in purple. No, yes, purple's good. So 2 times equation 1 is going to be 300 minus 2Q12 minus 4Q3 minus 60 equal to 0. We just stick in equation 2 as is. Q3 minus 30C equal to 0. We take the difference here because we're eliminating for Q12. And doing that, what do we end up with? And if you keep going, you get 90 plus 30C is equal to 3Q3. And you get that Q3 star is going to be equal to 30 plus 10C. So that's Q3, right? Q12 is going to be different. Presumably it's going to be lower because they get a discount on their marginal cost. If you just grab equation 2, you can grab equation 1 if you like, it doesn't matter. Minus, where was equation 2? Minus Q3, so let's sub in what we know Q3 is now. Minus 30C equal to 0. If you solve that for Q12, what do you end up with? 60 minus 20C equal to Q12. And then of course, big Q has to be equal to the sum of both. So you add this up together, you add this and this together. What do you get? You get 90 minus 10C is going to be big Q. And then if you want the price, that's going to be 150 minus 90 minus 10C, which then ends up as 60 plus 10C. So that's the price. And thus, finally to arrive at the profit of the merged firm, it's going to be the price that it charges multiplied by the quantity that it sells less its marginal cost times its quantity. And we can't forget the discount. And you can expand it all the way out. And if you suck at math like me, you would end up here. But if you're good at math, you'd end up here. Either way, they're both correct. Alright, so that's all we have time for. Are there any questions? Okay, cool. Consultation has been moved to 1 p.m. today, and that is it. Thank you. Oh, also, if you're listening at home and you've listened along this long, don't forget that you're not in the tute because you don't have to come, because there's recordings. And also, fun fact, the student feedback surveys are coming. Don't forget to give Steve great feedback. Yeah, so that's all. I'll be hassling you next week for it too. Thank you.